10 Astonishments about our universe. Since the time the disclosure of Pluto in 1930, kids grew up discovering that the nearby planetary group has 9 planets. That all changed in the late 1990s, when stargazers began contending about whether Pluto was for sure a planet. In a profoundly dubious choice, the International Astronomical Union eventually chose in 2006 to assign Pluto as a predominant planet, decreasing the rundown of the nearby planetary group's actual planets to only 8. Space experts, be that as it may, are as yet chasing for another conceivable planet in our close planetary system, a genuine 9th planet, after scientific proof of its reality was uncovered on January 20, 2016. The claimed Planet 9, likewise called Planet X, is accepted to be around multiple times the mass of Earth and multiple times the mass of Pluto. According to earthsky.org. Recollect Th1O's styrofoam models of the close planetary system we made in primary school? The close planetary system is significantly cooler than that. Here are 10 things you probably won't know. 1. The most smoking planet isn't nearest to the Sun. Many individuals realize that Mercury is the nearest planet to the Sun, well, not exactly 50% of the Earth's separation. It's no secret, accordingly, why individuals would accept that Mercury is the most sweltering planet. We realize that Venus, the second planet away from the Sun, is on the normal 30 million miles, 48 million kilometer, farther from the Sun than Mercury. The regular supposition that will be that, being farther away, Venus must be cooler. Be that as it may, presumptions can be perilous. For common sense thought, Mercury has no air, no warming cover to assist it with keeping up the Sun's warmth. Venus, then again, is covered by a startlingly thick environment, around multiple times thicker than Earth's climate. This in itself would typically serve to keep a portion of the Sun's vitality from getting away, go into space, and accordingly raise the general temperature of the planet. Be that as it may, notwithstanding the air's thickness, it is made primarily out of carbon dioxide, a potent greenhouse gas. The carbon dioxide openly gives sun-oriented vitality access, yet is significantly less straightforward to the more extended frequency radiation produced by the warmed surface. In this manner the temperature ascends to a level far above what might be normal, making it the most sizzling planet. Actually, the norm earthsky.org web link temperature on Venus is around 875 degrees Fahrenheit, 468 degrees Celsius, sufficiently hot to soften tin and lead. The most extreme temperature on Mercury, the planet closer to the Sun, is around 800 degrees Fahrenheit, 427 degrees Celsius. What's more, the absence of environment makes Mercury's surface temperature differ by many degrees, though the thick mantle of carbon dioxide keeps the surface temperature of Venus consistent, barely shifting by any stretch of the imagination, any place on the planet or whenever of day or night. 2. Pluto is littler in breadth than the U.S. The most noteworthy separation over the bordering United States, from northern California to Maine, is almost 2,900 miles, around 4,700 kilometers. Because of the New Horizons rocket in 2015, we presently realize that Pluto is 1,473 miles, 2,371 kilometers, over, not exactly a large portion of the width of the U.S. Unquestionably in size it is a lot littler than any significant planet, maybe making it somewhat more obvious why, in 2006, the International Astronomical Union changed Pluto's status from significant planet to dwarf planet. 3. George Lucas doesn't think a lot about space rock fields. In numerous sci-fi films, shuttle are frequently imperiled by bothersome space rock fields. In reality, the main space rock belt we know about exists among Mars and Jupiter, and despite the fact that there are a huge number of space rocks in it, maybe more, they are broadly dispersed and the probability of slamming into one is little. Truth be told, rocket must be purposely and deliberately guided to space rocks to get an opportunity of capturing one. Given the assumed way of space rock creation, it is profoundly far-fetched that spacefarers will ever experience space rock multitudes or fields in profound space. 4. You can make springs of gushing lava utilizing water as magma. Mention volcanoes and everybody promptly considers Mount St. Helens, Mount Vesuvius, or possibly the magma caldera of Mauna Loa in Hawaii. Fountains of liquid magma require liquid stone called magma, or magma when still underground, isn't that so? Not so much. A well of lava structures when an underground repository of a hot, liquid mineral or gas ejects onto the outside of a planet or other non-heavenly galactic body. The specific arrangement of the mineral can change incredibly. On Earth, most volcanoes sport magma, or magma, that has silicon, iron, magnesium, sodium, and a large group of convoluted minerals. The volcanoes of Jupiter's moon Io give off an impression of being made for the most part out of sulfur and sulfur dioxide. Be that as it may, it tends to be less complex than that. On Saturn's moon Enceladus, Neptune's moon Triton, and others, the main thrust is ice, old-fashioned solidified H20. Water grows when it freezes and tremendous weights can develop, similarly as in a typical fountain of liquid magma on Earth. At the point when the ice ejects, a cryovolcano is shaped. So volcanoes can work on water just as liquid stone. Coincidentally, we have generally little scope ejections of water on Earth called fountains. They are related with superheated water that has come into contact with a hot supply of magma. 5. The edge of the nearby planetary group is multiple times farther away than Pluto. You may in any case think about the closed planetary system as reaching out to the circle of the much-cherished midget planet Pluto. Today we don't look at Pluto as an undeniable planet, yet the impression remains. In any case, we have found various items circling the Sun that are significantly farther than Pluto. These are trans-Neptunian objects, TNOs, or Kuiper Belt objects, KBOs. The Kuiper Belt, the first of the Sun's two repositories of cometary material, is thought to reach out to 50 or 60 galactic units, AU, or the normal separation of the Earth from the Sun. A considerably farther piece of the nearby planetary group, the tremendous yet shaky Oort comet cloud, may stretch out to 50,000 astronomical units from the Sun, or about half a light-year in excess of multiple times farther than Pluto. 6. Nearly everything on Earth is an uncommon element. The basic creation of planet Earth is for the most part iron, oxygen, silicon, magnesium, sulfur, nickel, calcium, sodium, and aluminum. While such components have been recognized in areas all through the universe, they are just follow components, boundlessly eclipsed by the a lot more noteworthy bounties of hydrogen and helium. Consequently Earth, generally, is made out of uncommon components. This doesn't connote any unique spot for Earth, be that as it may. The cloud from which the Earth shaped had an a lot higher plenitude of hydrogen and helium, yet being light gases, they were crashed away into space by the Sun's warmth as the Earth framed. 7. There are Mars shakes on Earth, and we didn't bring them here. Chemical examination of shooting stars found in Antarctica, the Sahara Desert, and somewhere else have been appeared by different intents to have started on Mars. For instance, some contain pockets of gas that is artificially indistinguishable from the Martian environment. These shooting stars may have been shot away from Mars because of a bigger meteoroid or space rock sway on Mars, or by a gigantic volcanic ejection, and later crashed into Earth. 8. Jupiter has the greatest expanse of any planet, albeit made of metallic hydrogen. Circling in chilly space multiple times farther from the Sun than Earth, Jupiter held a lot more elevated levels of hydrogen and helium when it framed than did our planet. Truth be told, Jupiter is for the most part hydrogen and helium. Given the planet's mass and compound structure, material science requests that down under the virus cloud tops, pressures ascend to the point that the hydrogen must go to fluid. Indeed there ought to be a profound planetary expanse of fluid hydrogen. PC models show that not exclusively is this the biggest sea known in the close planetary system, however that it is around 25,000 miles, 40,000 kilometers, profound, generally as profound as the Earth is near. 9. Indeed, even tiny bodies can have moons. It was once believed that solitary articles as extensive as planets could have normal satellites or moons. Indeed the presence of moons, or the ability of a planet to gravitationally control a moon and circle, was at times utilized as a feature of the meaning of what a planet genuinely is. It simply didn't appear to be sensible that littler divine bodies had enough gravity to hold a moon. All things considered, Mercury and Venus have none by any means, and Mars has just little moons. In any case, in 1993, the Galileo test passed the 20-mile-wide space rock Ida and found its 1-mile-wide moon, Dactyl. From that point forward, moons have been found circling numerous other minor planets in our nearby planetary group. 10. We live inside the Sun. Normally we think about the Sun similar to that huge, sweltering bundle of light 93 million miles, 150 million km, away. However, the Sun's external air reaches out a long ways past its noticeable surface. Our planet circles inside this questionable air, and we see proof of this when whirlwind sunlight-based breeze produce the northern and southern lights. In that sense, we unquestionably live inside the Sun. In any case, the sun-powered air doesn't end at Earth. Auroras have been seen on Jupiter, Saturn, Uranus, and even far-off Neptune. Truth be told, the external sun-based climate, called the heliosphere, is thought to reach out at any rate 100 AU, that's about 10 billion miles, 16 billion km. Truth be told, the climate is likely tear-formed because of the sun's movement in space, with the tail stretching out tens to many billions of miles downwind. How do you account for their existence? The Holy Book says. Of course, every house is constructed by someone, but the one who constructed all things is God. Hebrews, verse 4.